In the last video, I did ask you to read these long paragraphs for example 5. So go ahead, if you haven't already, pause the video. Please read this before we get started because it has a lot of good information in it. Okay. So we're going to talk about blocking. Okay. So in this case, we're talking about typing speed. So for example, they're trying to test out like a new keyboard. Okay. When your like Apple doesn't update, they change the keyboard and it throws you off for like 2 weeks because you have to learn how to type on it. So I think they've kind of streamlined it now, but man, I just remember when it used to change all the time. So they're testing out keyboard designs, right? However, in this scenario, maybe this was a little bit outdated because we have some volunteers who already have a smartphone, some people who don't have a smartphone. Well, the company, obviously the people who don't have a smartphone, their typing speed is going to be worse because they're just not used to typing on a smartphone. So let's not talk about our blocked scenario. Let's talk about if we didn't account for this, okay? If I'm really assigning people randomly, it could be possible. Doesn't mean it's likely, but it could be possible that I had 10 volunteers and there's 6 volunteers who don't have a smartphone. So what if I assign to keyboard A, it ends up being the 5 non-smartphone users, okay? And then to keyboard B, there would be 1 non and 4 smartphone users, okay? Well, keyboard A is going to look a lot worse because A has all the non-smartphone users. B has all of the people who already use smartphones. So B is going to look better just because these people have experience typing on the keyboards. What we want to do is we want to separate. I know that whether or not they use a smartphone, I know this is going to be a confounding variable. So I am going to block on this variable. I want to control for the whether or not they use a smartphone because I know that that's going to cause me problems. Okay. Since I think this is a confounding variable, I am going to block on that confounding variable. Let's look at this little chart right here. Okay, we're going to make a lot of these charts whenever we are assigning people to experiments. Okay, so I have my 10 volunteers. This is where they get put in their block. Okay, and I want you to note that their assignment to the blocks is not random. I am forcing all the smartphone users in one block and all the non-smartphone users in another block. Here is where the aspect of randomness comes in. Okay, and it doesn't say how we're randomly assigning. We're not worried about that. We just know there has to be some aspect of random assignment. I'm going to send half of them to keyboard A, half of them to keyboard B in both groups. That way I know there are some smartphone users in keyboard A and there's some non-smartphone users in keyboard A. Same thing with keyboard B. I know I'm getting some people who have experience and some people who don't. Then I want to compare their typing speed, and at the end, we will combine them together. Okay, we still want to ultimately get back to just, the 10 volunteers and comparing the results, but we're going to take, a kind of complicated process to get there. Okay, some good definitions for you. A block is going to ensure at the beginning of the experiment, the units within each block are already similar to each other. Okay, so this is going to separate the natural variability, right? A smartphone user just has a natural variability. They're going to know the keyboards maybe a little bit better, even if it's slightly different. Definitely a lot more than a non-smartphone user. Okay. A randomized block design, this is the gold standard. We do want some aspect of randomness, so we will assign within the block, we will assign them to treatments randomly. Here's the results from our experiment down here. So I want to look first at this one. This would be just if I let everybody have the good typing speed. Okay, so I'm sorry, everybody just randomly, doesn't matter if you are a smartphone user or not a smartphone user, you just get randomly assigned. Okay, so this is what that would look like. Then we could break it up. We could see our smartphone users versus our non-smartphone users. Our smartphone users, you'll notice, are at the top over here at both keyboards. And then we could adjust the typing speed. We didn't really get into what this looks like, but they did do some sort of adjustment on the typing speed. It doesn't really matter what they did, but to kind of overlay them, now you can really see that keyboard A is a lot better. Okay, so the key thing here, I put it in bold, control what you can. Okay, if you have aspect of control, control it. If you can't control it, we'll block on this variable. And then we need to randomize in order to have good comparable groups. All right, let's look at this next example here. This next example says men and women respond differently to advertising. Great. Researchers want to design an experiment to compare the effectiveness of 3 different advertisements for the same product. Okay. In example, or in part A, it says explain why a randomized block design might be preferable to a completely randomized design for this experiment. So why do we care about blocking? Well, honestly, it tells us here in the problem, right? Women and men respond differently to advertising. So if they respond differently, we might want to have a certain number of women and a certain number of men assigned to both advertisements. That way I know that I've got some women and I've got some men in the advertising. All right, so let's make one of those trees that we looked at on the last page, and let's make this randomized block design using our 300 volunteers. Okay, so it does say describe how you would carry out the random assignment, because we are just going to put random assignment on there. I actually don't want to do that right now, but I want you to think about the ways that you could randomly assign. Remember, being very specific about the random assignment. Okay, so ultimately I'm going to start with 300 volunteers. Okay, that's my starting point. But we've said that men and women are going to respond differently. So I'm going to block based on if I have a woman or a man. And I'm going to put how many people I have. Let's see, I have 120 women and 180 men. But I do still need an aspect of randomness, right? So I am going to randomly assign them to the different treatments. In this case, they're different advertisements. So I'm going to have random assignment for both. I want to make sure that we have an equal number of women at each different ad and an equal number of men at each different ad. And there are 3 advertisements. So I'm going to send them to the different ads. So I could have ad 1, ad 2, ad 3. I have 120 women, so that makes, what, 40 at each? Okay, that's still enough that I have some sort of replication, right? I'm not just assigning 1 woman to each ad. I have 40 women in each ad, so I have enough people that this can actually work. Okay, I'm going to do the same thing for the men. And we would have 60 at each of those. Okay, still enough. We've got replication. We're feeling good there. All right, I'm going to first compare inside just the block of all the women. Okay, so I'm going to compare their responses. I guess, yeah, we're comparing, really it's the reaction or the effectiveness, but I'll just compare the responses to the ad. I'll do the same thing within just the men. Okay, it is at this point where maybe you find out that ad 2 really works for women and ad 1 really works for men. Or maybe it's that ad 1 works for both. But it's in here that you kind of gather some extra information, right? Like we might know, okay, maybe ad 1 is not great for men, but maybe ad 1 is really great for women. Maybe ad 3 is really great for both. We don't know. Okay, so it's in here where you can find some comparison inside your block. Okay, and you might find out some really useful information there. Ultimately, remember, we want to bring it back to, again, our 300 volunteers. So we're going to compare the results. And that may be finding that ad 2 is the perfect ad. It targets both men and women. It's great. Maybe when we get to our comparison at the end, we find out ad 3, it's terrible. Nobody responded to ad 3. Get rid of ad 3. But ad 1 worked well for women, and ad 2 worked well for men. Okay, and we don't know obviously what this is going to result in. However, we have some aspect of comparison there. Okay. Okay, there is a special type of blocking called matched pairs, and that is where you kind of pair people up based on relevant factors. We're going to really dive into this in class. Okay. Each pair would get the 2 treatments. So not both people, one person from the pair would get treatment 1 and one person from the pair would get treatment 2. Or maybe you have 3 treatments in which you want to arrange a group of people of 3 based on things that are the same. Okay? And it is important to note that you could serve as your own pair. So maybe if I'm looking at a placebo drug, maybe I have you take the actual drug for 1 week and I have you take the placebo for the next week. not telling you which one is which. And we see how, whatever the drug is supposed to do, we see how it works based on those 2 different weeks. Okay? This is kind of the ultimate form of blocking, because now, even within the women, all women are different, okay? And there's still differences within women. Same thing with men. Men are all still different. In matched pairs, you're going to find 2 people that are as similar as you can. And maybe it's that same person. Maybe you are serving as your own pair. You are a perfect match to yourself. And then we're going to start to make some comparison. Okay. So what a tree would look like for this, we're just going to look at a generic tree, and then we'll do an example in class. You have all your units. You break them up into pairs. You get a random assignment within the pair. One person goes to treatment 1, one person goes to treatment 2, and then you're going to compare the results at the end. Okay, that's matched pairs. Like I said, we will really dive into matched pairs a little bit later. It is like the ultimate form of blocking.